G'day everybody. Welcome to discovering the basics of Lightning UI performance testing. Just a reminder, we love feedback. Please give feedback. You might get something. Thank you for being at this session. Obviously there's a lot of excellent content here at Dreamforce, and there's lots of interesting stuff out there, so I appreciate you being here. My name is Craig Suthers. I run a company called Grandstand Performance, and I have been in the tech world for about 25 years, 5 years of which I spent at Salesforce, running their Lightning performance organization, which included releases like LWC and Dynamic Forms for some examples of what we put out during that time. Today we're going to talk a little bit about the what and why we do performance testing. We're going to get into some code. We're going to go back to school a little bit, do some reminder of how statistics work and why we use it in the performance context. And then we're going to go look at some data. And that will be 20 minutes of lots of information. Performance testing. There's lots of different testing. You've probably heard of integration testing, unit testing, maybe stress testing, security testing, accessibility testing. Today I'm going to be talking about performance regression integration testing for a mouthful. Integration testing is when you bring the whole application together. So in this context, we'll be talking about the web application of Salesforce. Performance testing, we're going to gather performance data, and regression testing means we're going to compare yesterday to today. What was the website performance yesterday? We made a change. What's the performance now? Is it better or worse? Why is it important? There's lots of reasons. One, it's user happiness. There's actually lots of research around the psychological and physiological effects of slow applications. It's data cleanse, it's data completeness. If you have to keep the context in your head of what you want to put into a system while a text message comes in or a Slack message, and then you've got to try and remember to get it in, that's going to get dirtier as time goes on. And in this AI sort of first world, data cleanliness is super important. And the old adage, time is money. There was just a slide template that said put a quote, so I put a quote. It has nothing to do with performance, just makes me giggle. Knowledge is knowing that tomato is a fruit. Wisdom is not putting it in a fruit salad. That'll make me happy for the rest of the session. All right, the performance challenges with Salesforce are many. It is what we call a single-page application. Traditional websites like Classic was a multi-page application, and they execute different, so I'm just going to run very quickly through some of the differences. A traditional website, you go get the HTML, and the browser will automatically start rendering that. It'll go fetch some JS and some CSS, and now you have a very pretty picture with lots of information. The browser is highly, highly optimized for that process. Single-page applications, on the other hand, we hijack that process. We build our own sort of mini OS that executes in the browser, that runs the browser for us and manages components and rendering. So initially we have to bootstrap that. We get a HTML, but this is just a link to some JavaScript files. Nothing's rendered yet. Lots of time might have gone by. And then we start the page layout. So this is every execution of a page from this point. You get the page JSON, it's metadata about the page. You go get the components, you go get the metadata about the objects, you go get the data, and then the controller can actually render the page. One's not necessarily better than the other. SPAs were fantastic for highly dynamic, interactive web applications, and why Lightning went in that direction. I'm a coder, so we're going to get to some code now. What is a performance test? The best performance test is an integration test that captures some extra data. So here's a super simple integration test. We go to the login page, we get a username and password, we stick it in there, we click the login button, and in an integration test, here we'd assert a truth. Does this field have this value? Is this, language the right word for German, for example? For performance, we go get stuff. How long did it take? How much memory did we use? How much network activity was in play? Hard drive, you name a resource, we want to capture the data for that. now I can go and relax into some code. Here's exactly that same code. And we're going to just go pop over here and run it. npm, well, let's see if it works in capitals. Basic. No. So we just go and run that. We log into the page, and we're there. And at this point, we now need to capture some data. Now, if you're in a multi-page application or a traditional website, there is a ream of standard web vitals, they're called, performance metrics available from the browser, consistent in every browser that you can use for performance. Not in a single-page application. There is no standard today. So Salesforce had to go and make their own definition of what page load time meant. So let's jump back to the slides. And they created a thing called EPT. I apologize I didn't spell it out here. It stands for Experience Page Time. If you use event monitoring, for some reason there it's called Effective Page Time. But anyway, it's the measure that Salesforce uses from start to end of a page load. There are some easy ways to get it. If a user or a customer calls and says, my page is slow, you can just add this EPT visible equals 1, and you'll get this nice little EPT there that's there all the time. Great for ad hoc debugging of whether it is slow from Salesforce's point of view, can be very different from perceptual slowness. You can get rid of it by doing equals 0. From a coding point of view, I don't rely on that. I rely on data that Salesforce pushes into the browser. Every browser, it's absolutely standard across all major browsers, is a performance API. You can go and look at it in the dev tools. We'll look at it in a second to capture that information. And obviously then, if it's there, you can code it. So here is some code. It's exactly kind of what I just showed. So I have this bit of code that says, I'm just going to wait until there's a new bit of performance data for this thing called page EPT. And once it gets that, I can say success, page has finished loading, and I can make another call then to go and fetch that EPT. And I believe I'm going to go to some code now. Happy days. So here's that code again to go and get that information. We're going to go quickly here, and we're going to have a quick look at those two ways of getting EPT that I showed you, because I'm running things backwards today. So if we do EPT visible equals 1, you'll see that I typed it in incorrectly. EPT visible equals 1. There we go. There's that beautiful little EPT visible. Now, you can go to DevTools. There's lots of ways. If you don't know about Chrome DevTools and you're a web front-end person, please learn about it. I have links at the end of this that you can go and learn more information. But one easy way is just to go and inspect. You go to console, and then you have the performance API available to you. So performance.get entries by name. It's called page view EPT. And you'll get this object back. It's an array. And so every time there's a page load, it will add a new value to this array. And in this, there's a bunch of information, but really what we care about is this duration. And the duration here, 793 milliseconds, which aligns to what we have here for 0.79 seconds. All right, so that was fun. Now I'm going to talk very briefly about some statistics, some very basic statistics. Mean, or average, is the sum of the data set divided by the number of items in the data set. So for this data set, there's 5 things. We get a mean of 171. Median, on the other hand, is the middle of that data set. So we sort the list, we find the midpoint, and in this case, the median's 170. Now, the reason I'm giving you this very basic stats lesson is it'll come back. It's one of those you got to wait till the end scenarios. But if we look at this other data set, the only difference is that first one is 1,500 units, and it blows the mean out. It's 436. If we look at the median, you'll actually see it's the same number, and that's really important. And again, it'll come later. Standard deviation is also super useful. The algorithm for that, no one needs to care about. Computers do that calculation for you. And the standard deviation for that first data set is 5.1, and it's 596 for the second. And so it shows the distance from the average or the mean in the graph of numbers. And so if there's big outliers, you'll see a big standard deviation. What you want is a really nice tight standard deviation when you're doing performance testing. All right, we got that school out of the way. Let's go look at another test. So we're going to do a little bit more now. We're going to log in. We're going to go to Account Object Home. We're going to click that tab button there. We're going to go to the first item in that Object Home list for accounts. We start a browser. We end a browser at the end, which means we delete the session, which means we get rid of all the cache. And it's really important for performance testing because there's a lot of caches in the front end of Salesforce. There's a lot of caches end-to-end in Salesforce. But this means we know at the start of the test the state of the cache. We don't have to worry, is something cached or not. When you look at the numbers, you can say, hey, each of these numbers is consistent in terms of caching at least. So you can rule that out as one of your performance problems in general. And then we go and run the test multiple times. I have 5 here just because of time. So what we're going to do is just make sure I didn't forget a slide to show you. No, good. And so we'll go run that test. npm run EPT. So while that's running, that's just to distract you from looking at me. You can look up there instead. The reason that we run it multiple times is for performance and statistics in general. One of the things we want to do is reduce the noise in the system as much as possible. So if we ran it once today and we run it once tomorrow, maybe the network was really busy. Like at the moment we're running on the network here, there's thousands of people all connected to it, and that's going to have an impact on my page load performance. Tomorrow I might be doing it at 5:30 in the morning and no one's here, and it will be faster just because of the network time. So we run it multiple times to try and iron out some of those variances that are in the system. I just gave you a very extreme variance, but it could be Chrome update ran in the middle of one of your tests. So there's, you want to run it multiple times. You want to run it on a very clean machine, as clean as you can make it. You want to disable as many services. Don't run anything else except for the test and the browser. And that gives you like 100% of the CPU is focused on what you're trying to do. 100% of the network's on what you're trying to do. And that, again, will reduce noise of the system. And the third thing you want to do, and the reason that I showed you mean, median, and just to give you a brief reminder of that, is that we use median to do comparisons. And the reason that we use median is because of that outlier problem. If we looked at the mean of data, we would be chasing performance bugs forever because any single outlier will just skew the data set. So let me give you an example. This is the data that we just run. We collect some basic OS information. Down the bottom, you'll see some window size information, and that's to make sure that maybe I started and it just was in a different proportion for some reason. Something might have happened in the system that will give you different performance results. So we want to know a whole bunch of information about the system at the time of running. And we see here for the home page, which is just that first landing page, we have a median of 1.1 seconds with a standard deviation of 70 seconds. You'll probably see that standard, whoa, that is incredible. Like 2 is, I've never seen that number before, so this is the best demo ever. And this is more like what I expected to see in this session, something in the 100 millisecond range, primarily because the network's running. I'm also running visual code here. I've got a slideshow running underneath. OS is doing whatever the OS is doing. So we use median specifically to, one, we want to look at median in context of standard deviation, but we use median to try and get that noise of the outliers. Outliers are still super important. It's a real number. It actually happened in the system. You can't just discard it and go, yeah, we don't care about that slow one, because what happens in the lab isn't necessarily what happens in production, and maybe the conditions that got you that big number is something you will see in production. So it's worth investigating. Alrighty. I got lots of time left. So we talked about clean computer, lots of runs, median as the way we look at the data, so that's kind of how we try and reduce the noise in the system. In any lab I run, I want that standard deviation to be below 30 milliseconds. And the reason for that is the how sensitive the data is to knowing if there's a performance issue is somewhat relative to standard deviation. There's a rule of thumb that we use. I'm not any great statistician, so please tell me if I'm absolutely wrong, but people who are smarter than me have told me the rule of thumb here is you double standard deviation. So if you have I love the 2 millisecond, if you have this 167 milliseconds standard deviation, that makes your ability to find a bug less than 200 milliseconds essentially impossible. You don't know whether it's truly there or it's a defect in the noise in the system. So that's why we try and get that standard deviation down to find small bugs, because small bugs in the lab can be big bugs in production. It's just the way the system seems to work. There is one last thing that I want to touch on in terms of these tests. I kind of hit it to start with. You may already be aware that with LWC components, they implemented a shadow DOM. It's a polyfill. They're not using native shadow DOM. There's some work going on to address that. And shadow DOM makes testing difficult. You'll see here, in a non-shadow DOM system, I could just put this into my query selector and I would get the node. But because of shadow DOMs, we have these things called shadow routes, and there's lots of them here. So each one of these lines is me accessing the next level deep in a shadow route. And I only tell you that because even though I knew about shadow DOM when I started my company, I actually hit my head against this for about an hour going, why can't I find this selector? So even when you know, sometimes you forget. There are ways around it, and again, I have links at the end for you to see how that shadow DOM and how to get around it actually works. And Salesforce actually provides 2 libraries that will help you do that in your testing. And WebDriver IO also now supports shadow DOM traversal, so it looks like normal selectors. Alrighty, that is pretty close to the end of the talk. So just to recap, and this is actually somewhat new, but recap. How do you get started in this? And essentially the answer is just do it. It's the only way you can start anything. I think that performance is the next step in the maturity of any testing organization. Unit tests are fantastic, integration tests are great, and that gives you confidence that the site works. But non-functional, and performance falls into the non-functional requirements, is what your customers actually see. And Salesforce has done a lot. You may have seen a blog post just recently from Bogdan, one of the PMs, on how they've reduced at the P75 the EPT for all Salesforce customers. But there's a truism in Salesforce, which is the more you put onto a page, the slower it's going to be. And so if you're adding a component, you are going to slow the page down. There's almost no way around it. So understanding what that impact is really important. For goals, please, if you're just a solo, then maybe you can find 10 minutes just to think about how fast you would like this activity to be for your customers and your users. If you've got a bigger team, work with your business analyst, your PM, product management, whoever is interested in this stuff to set goals. Ideally, don't look at production and go, that's my goal. Actually think about how your users interact and what they would get out of it if you had good performance goals and were meeting them. One thing in the research, if you actually follow through any of the links that I share at the end, anything over about 2 seconds is actually where the point of starting to tax your mind to try and remember that information by the time the page loads. So anything after that, you're so easily distracted that you may forget, and so that's why ideally your performance goals should be under 2 seconds. Once you've set that goal, then actually go see what it is. Go run it in a lab, in a nice clean environment. I know it's not production, but it'll give you some good ideas of where some performance hurdles are. And then look at the real user metrics. RUM, I should have written that out, I apologize. So collect RUM either way. I'm good with just the definition of RUM normally. But real user metrics is really what you want to have at the end of the day. What are your customers really seeing in their environment? And then you can make plans to improve. And then finally, as I've already gone on about a little bit, reduce the variance. Clean up the machine. Use multiple iterations. 5 is not the right number. It's just a number I chose for expediency. But it's different depending on the page and how much noise there is in the page. And then median over mean is the other important thing. Thank you. Thank you for coming. There's more slides. Here's the resources. This deck is linked there, so is the demonstration code. There's a whole bunch of blog posts on the things that I've talked about today. This is a lot of content for something that people probably don't have a lot of knowledge on already. I don't have time for Q&A, but I will be over here somewhere around. Please come and ask your questions, and I'll be here for the rest of the conference. Surveys, please. This is actually going to be summarized by Einstein. I am fascinated to learn what it's actually going to think about this talk, whether it understands Australian. So thank you very much for turning up, and enjoy the rest of Dreamforce.